Um, okay, so we're going to use logs for these modeling questions. Have you seen a question like this before?
No,
Okay. Normally people find them harder, but they're very repetitive once you get the hang of it once. They're the same every time. So let's see. So every single time you're going to get a straight line graph and you're going to have an exponential equation. This is your exponential equation, okay? Because it's something to the power of something. Does that make sense so far?
yeah,
Okay. Um, I wanted to go over the graphs again one more time because we sped through them very, very fast before. An exponential graph, do you remember what shape it always has? Does it go
no,
up? Does it go down? Like how is it shaped?
I can't remember.
Okay. Can you give me an example of an exponential graph, like y equals
K squared x.
um
K to the power of x.
that's it, k to the power of x. So y equals e to the power of x, k to the power of x. Let's pick a nice number. So let's just pick 10. 10 to the power of x, okay? So minus 2, minus 1, 0, 1, 2. Can you tell me the numbers that would go in there? If those are your x, what would your y be? So what's 10 to the power 0, 10 to the power 1, 10 and so on?
10 to the power of minus 2 is 0.01.
Good. 1 over 100.
And then 1 over 10.
Yeah.
And then 1, and 10, and 100.
Good. And what would 10 to the power 3 be?
1,000.
So it's going up a lot, isn't it?
Yeah,
And is it going negative at all? Or is it just going towards?
they're just positive.
Yeah. And what's the lowest number it will go towards?
0.
Good. And it won't ever touch 0, but it will go towards 0. Does that make sense?
Yeah,
That's important because you know those 1 mark questions, they ask stuff like, what's the population going to be in 1,000 years? Or what's the population going to be when the tree dies? Or that kind of thing. And you have to substitute a big number and see where it goes towards. Does that make sense?
yeah.
It looks like that. And it goes through 1. Okay? Now, these types of exponential graphs can be modeled as a straight line as well. Why would anybody want to do that? Well, it just makes it easier for people to see patterns and understand like how two things are related to each other. We don't have to know exactly why, but it just makes sense. It makes more sense if we understand briefly why that happens. So we have this curve on the top right, but it's been remodeled as a straight line. Okay, so let's understand how they changed it to a straight line. H equals PM to the power of Q. First step we do is we log both sides. Use the same log that you notice everywhere else. So you know how you can have log with different bases. So they've used log with base 10, haven't they?
Yeah.
So log 10 H equals log 10 PM to the power of Q. How can I tidy the right-hand side up? Using any of the log rules. Think of rule 1 and rule 3.
I don't know which one you would use.
Just have a guess, don't worry if you make a mistake. What rules can you remember? So if you have P times M to the power of Q, what can you do with that?
Expand.
Kind of, yeah. So what do you mean by expand?
Like multiplying it.
So you are multiplying it, so therefore you can write it as two different logs. So you have log 10 p plus, what would you write?
Log m squared.
Log 10 m to the power of q. Yeah, that's a q, sorry, not a square. Yeah, okay. And then
Oh,
finally, what other rule can you use to do with the q?
the power rule.
Yep, so what happens? I get log 10h equals log 10p plus
2 log m.
q log m.
Sorry.
Yeah, it's fine. Could I have done that here or not possible? In step two, could I have brought the q down or would it not have been possible then?
Not possible because of the p.
Yeah. If it was pm all to the power q, you could have moved it down, but not because it's just the m, so you separate them first and then move it down. Um, Now we're going to come back to this question because there's 3 or 4 steps. It's about 7 marks in total, as is the next one. So can you do the exact same thing that we did for this question? Okay. So try to turn this into something that looks like this. I'll give you 2, 3 minutes. So for this a equals pq to the power t thing, how do we turn that into how do we rewrite that in what we're going to call a linear form? So what would be the first step?
And would you raise 10 on both sides?
Um, do you mean like 10 to the power a equals 10 to the like that?
Like,
How do,
yeah,
um first step is to log both sides. So we're going to write log 10a equals log 10 pq to the power t. Okay,
okay.
cool. Carry on from here. What would the next step be? How can you tidy up the right hand side? We're aiming for something like this. It's kind of like a show that in a way. I have purposely haven't let you read the question because it will confuse you, but we're just trying to turn this into something like this. So what would you do to the right hand side? Same thing from the previous question. Can you separate the p and the q to the power t?
Um, would you write it as log 10 p times log 10 q to the power of t?
Not times. What would it be?
Add.
Yeah. The main reason we're doing that is because we can't drop the t otherwise. So now we can. So what would the final step look like? What do we do with that?
T log 10 q.
Yeah. Okay. Now let's do it again. Same thing again. Can you turn this t equals al to the power b into something kind of like that? Let's do it together. So what's the first step?
Log both sides.
Yep. And use the same log you see in the question. So in this case, it will be log 10 again. So log 10 t equals log 10 al to the power b. Next,
You rewrite the second half.
the right hand side.
Yeah.
Yep.
Log 10 a plus log 10 l to the power of b.
Yep. And final step.
It would be b log 10 L.
Good. Okay. Now let's understand why we did all that. Okay. Because that was like, why are we doing all this? So, watch. I'm going to do all the questions again now. We're going to do the second step of every question. So, the question's asking us to work out P and Q. Now we've got this model, right? H equals PM to the power Q. We know that H is the heart rate of the mammal, and M is the mass of the mammal. So we obviously know that the higher the mass of the mammal, the higher the heart rate of the mammal, because it's an exponential graph, isn't it?
Yeah.
Actually, unless it's a negative, but anyway, there's a pattern between the two, but it makes sense if you have a heavier mammal, the heart rate might be higher. So, um, we want to find out P and Q so we understand exactly how they relate to each other, but we're only given a log graph for it. So this is what happens. Now, this is a straight line graph. Do you agree? The one on the diagram.
Yeah.
And what's the generic equation of the straight line graph? Y equals.
Mx plus c.
Mhm. So what's your y-axis on the graph?
Log 10h.
Underneath your log 10h, you're going to write y. What's your x-axis on your graph?
Log 10m.
So you're going to put your x there. So therefore, what's on its own on the graph? Like on the log 10h equals log 10p plus q log 10m.
2.25.
Uh, good. Is that your y-intercept or your gradient?
Y-intercept.
Do you think that is going to be the log 10p, or do you think that's going to be the q?
Um,
A better way to understand that is what's always next to the x in y equals mx plus c?
the gradient.
So this is always going to be your m. So that has to be your c. Does that make sense?
Yeah.
Okay, it's going to be confusing a bit, but we're going to do it again and again and you're going to understand it. What we've done is, so what did we do first? We rewrote our exponential model as a log or linear model, right? Then from the log model, we need to understand what's the y, what's the x, what's the m, what's the c. So the y is always what's on the y-axis, the x is always what's on the x-axis, the m is always what's multiplied by the x, and the c is just standing on by itself. Does that make sense now?
Yeah, it does.
Let's go to the next one. So they wrote that there's a linear relationship between t and log 10a. So log 10a is going to be your y, m, x, and c. Does that make sense?
Yeah.
So in our thing on the right hand side, I'm just going to put y underneath that. Where should I put my x?
Underneath the log 10p.
Y that one. It's not necessarily in order. It's more about what's the x-axis in the model, what's going along the x-axis. So they've got log 10a. And what's the x-axis? What are they modeling that against?
Wait, I'm confused.
Um, that's fine. Um, read the third sentence. Just read it out loud.
The one that says data recorded.
Yeah.
Data recorded indicates that there's a linear relationship between t and log 10a.
Mhm.
Given the equation, log 10a equals 0.03t plus 0.5.
Yeah. So linear relationship between t and log 10a. So t and log 10a are your x and your y axis. Okay. Does that make sense?
Wait, can you say that again, please?
T and log 10a are your x-axis and your y-axis.
Okay.
So log 10a is my y-axis. I'll help you with that. So then what's my x-axis? It's going to be the t, right?
Yeah.
So underneath I'll just put x. So I've got two more things, the log 10p and the log 10q. Which one's going to be my m? Which one's going to be my c?
Would c be log 10p?
Y. That's
Because the gradient has to be next to x.
perfect. Well done. There you go. So we had a model before, and it's in the form y equals mx plus c, and it's jumbled around, and we unjumbled it. It's c plus xm. Does that make sense?
Yeah.
Yeah. Last one. Um, in the diagram, what's the y-axis?
Log 10t.
Cool. So underneath this, can I write y?
Yeah.
What's my x-axis?
Log 10l.
Perfect. And then b, is that my m or my a c or something else?
M.
Perfect. So therefore the y-intercept is log 10a. Okay. So the first step of these questions are easy. You're just logging both sides and making it into that form they're showing. The second step is the hardest step. You need to figure out if it's y equals mx plus c, y equals c plus xm, y equals xm plus c. Like, do you know what I mean?
Yeah.
Cool. And then the final bit is kind of like, I'll show you now, the final step. Okay. So going back to the first question, we can finish it off now. I'm just going to tidy up, it's very messy. Y equals c plus mx. So I know that log 10p is my y-intercept. My y-intercept is 2.25. So I'm just going to write an equation. Log 10p must be equal to 2.25. Get it?
Yeah.
How do I solve that? From a few, like, before, you might have done it for practice. How do you figure out what p is?
You would do 10 to the power of 2.25.
Well done, very good. That's it. I'll put that in my calculator. And the answer is 177.8. And it wants it to free itself, so 178. Done. Okay. Now, how would I work out Q? Q must be equal to. So in our model, what's Q relating to?
The gradient.
And what is the gradient based on the text?
Minus 0.235.
Cool. So what's the answer for Q?
Would it just be minus 0.235?
Exactly. That's it. Done. Yeah.
Yeah.
Um, Now let's do this one. So we're doing these bits, which say work out P and work out Q. So according to our model, which one do you want to start with? Do you want to start with the Q or the P?
Uh, P.
Okay. So log 10P, what does that have to be equal to?
C.
Cool. And what does C mean? C stands for the y-intercept.
Oh, right.
And what is the y-intercept on the model? This one's weird because they haven't given a sketch, but just based on this model, what's the y-intercept?
0.03.
Isn't that the gradient?
0.5.
Yeah. So P equals
10 to the power of 0.5.
perfect. And then what about for log 10 cubed? What's my equation? What's it pointing towards?
M.
Yeah, and what is M in the model?
3.
So Q equals,
10 to the power of 0.03.
well done. Three 3.16 two and 1.07072. Okay,
Okay.
last one. Um, I need you to try to work out A and L. Wait, A and B, sorry. Ignore the Y. I need to work out A and B. And we've got all the information above and the diagram and the coordinates. Okay. So what am I going to equate together? Actually, I'll pause it. Take your time and think about this properly. Okay.
Okay.
So, if we have the model above log 10t equals log 10a plus b log 10l, and we've identified what's the y-intercept and what's the gradient, we can use the gradient to form an equation, and we can use the y-intercept to form an equation. Okay?
Wait, can you say that again, please?
We can use, you know how we've got the y equals c plus mx thing?
Yeah.
We know that this is the c and this is the m. So we should always, in these modeling questions, we're forming an equation by using the gradient, and we're forming an equation by using the y-intercept. Okay?
Okay.
What's different about this question compared to the other questions is in the other questions, did they give us the gradient straight away? Like, did they have it in the text?
Yeah.
Yeah, this one they don't. So can we just start by working out the gradient of the line? Can you do that first? What would it be?
1 second.
Just say it out loud. I'll do it in my calculator.
0.45 take away 0
Yeah,
over 0.21 take away 0 minus 0.7.
good. So we get 45 over 91. And then from our model, what should I equate that to? Should I equate it to like A, B, L, T, log A, log B, like out of everything on the right hand side, what which arrow is pointing to the gradient?
B log 10L.
B log 10L is mx, so what part is just the m?
B.
Yeah, that's it. So 45 over 91 equals B. We've worked out B now. Previously, before we got to this step, we identified that B is the gradient. So that's literally all we had to do to work out B. Just get the gradient.
Okay.
Yeah. So that's 0.4945. Okay, same thing with the y-intercept. This is testing you on your straight line graphs. So we need to first work out the equation of the line properly. I'm going to do that bit so that you don't get confused. So we have y equals 45 over 91 x plus c. What do you do to work out the y-intercept of a line when you have the gradient and the coordinates? Like in equation of a line topic, how do you find the y-intercept?
Would you do y minus y1
Mm.
equals x minus no
X.
m, yeah.
You can do that. And then do you remember the GCSE way or you don't remember that one?
I don't remember that one.
Okay. We can just sub in any coordinate we have. So we can just sub in the minus 0.70. But if not, your other method would also work. So we can just substitute them for x and y. So 0 equals 45 over 91 minus 0.7 plus c. And then c equals, just rearrange that. So we get 9 over 26. So log 10a equals 9. Oh, sorry, so I started rushing the last bit. So we worked out c just using another topic. So don't worry about that right now. Um, how do I apply it to this question? Well, what's my y-intercept from my model on the top right?
Log 10a.
Exactly. So log 10a has to be equal to
9 over 26.
exactly, and a equals 10 to the power of 9 over 26. Yeah,
Yeah.
good. 2.219. 2.22 because it's 3SL. Okay. Do you have any questions or you need to practice more to kind of figure it out?
I think I need more practice.
Okay, cool. So that's perfect. We'll do practice now. So just to recap one more time, it's always the same sequence of steps. Just read the question each time and understand what's different. But generally, you're changing an exponential model like this into a straight line log model like this. And you're understanding which one is the y, which one's the m, which one's the x, and which one's the c. And you're using that to form an equation from the gradient to find a or b. And you're using that to work out an equation for the y-intercept to work out a or b. Okay? Sorry, a or l and wait, is it a now? Yeah, a and b. Okay?
Okay.
Now in this question, we did the same thing, didn't we? We changed an exponential model to a loggy straight liney model. We understood what's the y, what's the m, what's the x, and what's the c. And we made an equation using the gradient, and we made another equation using the y-intercept. Okay. Can you try to explain in your own words? Don't worry if you make a mistake. The same thing again. What were the main steps for this question?
First you log both sides of the equation.
Yep. And you rearrange it to the form like that. Good. How do we know if the form, so the form should look similar to a, what type of graph?
A straight line.
Yes, well done. Secondly, what do? We have to figure out what's
The gradient and the y-intercept.
perfect. And then finally, we solve our equations. Yeah,
Yeah.
perfect. Well done.